Let's discuss a question from thermodynamics. This is basically to calculate the mean effective pressure of the cycle in Otto cycle. Now, if you recall the Otto cycle in a PV diagram, well, after suction there is a compression, then the constant volume heating, then the expansion, then the constant volume heat rejection. So this is your V1, that is the maximum volume at TDC. This is the minimum volume present. Now the compression ratio, which is gamma, is the total volume by the compression by the minimum volume. So volume at TDC by volume at BDC, bottom left answer, and this is 8. Now the mean effective pressure, MEP, is defined as the total work done by the difference in the volume V1 minus V2. Now why is that? Now what does it mean is that if I happen to replace this with a constant pressure cycle, okay, in fact not at this, if I happen to replace this actual curve to a rectangle where V2 in the same volume range, V1 and V2, then the width, it's say MEP. So if I happen to replace an actual PV diagram with the rectangle such that the x limits are same, only the y limits is changed, but only thing similar is that the area under the curve PV diagram, the work done is equal to the area under this, then we say that it's an equivalent MEP diagram, and the width, the height is basically determines the mean effective pressure. So the mean effective pressure into V2 into V1 minus V2. So if you take the product of mean effective pressure into V1 minus V2, that is the area under the curve, and that is the work done in this case, and you are equating that to a work done in the actual case. So that is in a sense indirect way of finding out mean effective pressure. So now work done is already given. So MEP is work done, okay, per kg, because work done per kg is given, into mass, right, by V1 minus V2. Now V1 minus V2, now how do I find out P1? Now if I assume the ideal gas equation, P1 V1 is MRT1, okay, and we know that V1 by V2 is 8, so I can get V2. So from this I can write, okay, so V2 is V1 by 8, okay, so let's substitute that. MEP is work done per kg, which is given as 420. So work done per kg, okay, work done per kg by mass m by volume V1 can be written as P1 or MRT1 by P1, and minus V2 is V1 by 8, so it's MRT1 by 8 P1, okay. So this can be written, I don't know whether I'm making things simple or work done per kg into mass m. So this is MRT1 by P1 is volume V1. So this is 1 minus 1 by 8, that is 7 by 8 I can write, right? And now everything is known. We just need to substitute. Work done per kg is 420 kilojoules, remember. So 10 power 3 per kg, so mass is there. Now that cancels with the mass here. R is 287, it's ideal gas equation, so it's basically 0.287, so 287 you can write joules. Into temperature is 273, so 290 in Kelvin I am substituting, and the pressure here is given as 100 kPa, that is at the starting point, so 100 into 10 power 3 into 7 by 8. So basically what you are doing is you need to know V1 and V2. You have two relations, V2 by V1, V1 by V2 is 8 based on the compression ratio, and for V1 you use because air, you consider air as an ideal gas equation and you apply this. So it's just m will get cancelled, so 420 into 10 power 3 into 8 into 100 into 10 power 3 by 287 into 290. So this I get 576, close to 576 into 10 power 3, so that becomes 576 kPa. So the answer is close to 576 kPa. Thank you. So this is mean effective pressure of the cycle. Thank you.